Hello, everyone. I'm Robert Lutz, Director of Product Management at Systech Corporation. So this presentation, which actually may be the last one, I'm not sure, might be the most interesting presentation of the afternoon. So why is that, you might ask? In just a few, coming to the end here. In just a few short minutes, we're going to examine some of the most interesting topics to you, but also I'm going to do something crazy. I'm going to do an actual demonstration. I'm not talking about just showing an application up and running and working. I'm talking about building an application right here, and you guys are going to sort of help me and see how this is done. So we're going to create an industrial IoT application right here. So this is going to be fun. Let's get going here. So what's important for you in an IoT application project? Is it the fact that billions of devices will be connected to the internet in a while? Is it the fact that Socket IO or MQTT is used for communication technology? I don't think any of that is what's critical. I think you'd agree what's the most important thing is your success. So if you're an IoT customer, then your success is dependent upon meeting the business criteria that your project is based on. And that could be relative to business goals, it could be cost reductions, it could be customer satisfaction criteria. And if you're an IoT reseller or distributor, then your success is dependent upon meeting cost goals or schedules, or most importantly, providing a solution that works right the first time and every time. So there's a strong relationship between your success and the success of the IoT project that you're working on. So we all want IoT to be simple. Simple is used a lot in these battle presentations. Everything's simple. It has to be simple for us to be successful. It's like stacking building blocks. It has to be like child's play. And as a system integrator or a VAR, you don't want to spend precious resources sitting in a multi-day training seminar learning how to implement IoT hardware or IoT software. That could be a real time sink, and there's no guarantee at the end you can actually create an IoT solution that you really need. In fact, one of the earlier demonstrations that we saw, or presentations, talked about putting 2 engineers on the project for 2 weeks to create an IoT application. Well, we're going to do this thing right now in just a few minutes. So much, much faster, much, much easier, sort of an order of magnitude better. So it's like building blocks. You want to be able to interchange your solution. For example, you may need serial ports and cellular today, but soon you may want to add in Zigbee devices or analog inputs to meet whatever future IoT requirements might be in front of you. So time is of the essence. Creating a complete IoT solution and getting it up and running has traditionally required months and months of development time. The hardware needs to be designed, certified, built. Software needs to be created and debugged. This all takes time and money and usually results in a production date that's further out than you really want. Ideally, you want to reduce development time as much as possible. Well, that's exactly what the Systech SysLink Modular IoT Hardware Gateway and the SysScript IoT software is all about, and that's what we're going to be building with today. So, how are we able to do this? We're able to do this by tying the hardware and the software together, along with security technology to keep the network and things safe. It all starts with the hardware. So what you see on the screen here is a SysLink gateway. It's an IoT hub that can talk to just about any device and any communication protocol that might exist. And how does it do that? It does that with the little plug-in cards that you see on the screen. These cards exist for Zigbee and Z-Wave and Wi-Fi and cellular and Bluetooth, serial ports, all sorts of different interfaces. You just plug these option cards in and power up the gateway, and you're up in just a few seconds. These interfaces are critically important when you're talking about the industrial Internet of Things. Why is that? Because many of these applications require talking to legacy equipment, not just new fangled protocols and interfaces, but you want to be able to talk to serial ports or Modbus or even GPIO, analog or digital signals. So the gateway also ideally would support failover technology. So if you have an issue with a hardwired Ethernet, you could fail over to cellular and those kinds of applications. The communications need to be secure on all entry vectors, and this gateway does that. It supports advanced firewall and security features common to commercial routers, commercial-grade features of the routers. Also, the internet access is secured with HTTPS and OAuth for communication, and the end device security, like for the Z-Wave or Zigbee devices or things like that, is using the security technology built into those protocols. Also, to keep up with the latest security requirements, the gateway supports over-the-air updates, so it's available for software updates as well as firmware updates. So the hardware that I showed you has been in production for quite a while now. It's proven to be quite successful. More recently, we introduced the script software. With the embedded Linux operating system, you can support local edge computing. And actually, this is the gateway right here that we're going to be demonstrating with up and running here. So it's got embedded Linux operating system in it, but we're also integrating SysScript software technology. And SysScript is a beginner-friendly scripting solution that anyone can use for the Internet of Things. And when I say anyone, I really mean anyone. You don't need to have a technical background to be able to program with SysScript, and we'll be showing that here right in just a few moments. So it's super simple to write these scripts. So let's go through an actual demonstration. So I've done demonstrations in the past. We've done things like refrigeration units and things like that. Today I'm going to do an industrial Internet of Things application. This will be, let's go through this example where you are a VAR, let's say, or system integrator. You're going to a customer. And they have an IoT need. So this is how you might go through that customer meeting. So you meet with a company, let's call it Lift Incorporated. It's an elevator maintenance company responsible for thousands of elevators used in shopping malls. And this company explains they need a solution that notifies maintenance if an elevator regularly exceeds its landing location, when the elevator lands at a certain spot. And also, this must take into account the weight of the occupants. It's not just a fixed value. If you cross this threshold, you have to take into account the weight. So this application for the Lift Incorporated is going to save them thousands of dollars due to reduced service calls, so fewer service calls and preemptive maintenance, so they can eliminate the more expensive repairs that might otherwise be necessary if you wait until there's an actual more severe failure. So this is great. You're the system integrator of VAR. You say, that we can create. I'll talk to our engineers. We'll get together shortly, and we'll show you a proof of concept so we can get this up and running. And so the customer's going, well, how soon is shortly, right? Was this weeks? And also, as the VAR, where are you going to actually find those resources to be able to develop that proof of concept? So imagine that same meeting, alternatively, where at the end of this description, you pull out something like this gateway, some hardware devices, and tie it all together from a hardware perspective, and then take out your iPhone, program in some scripts, which we'll do in a moment, and then show them in just a few minutes, is this what you're talking about? Is this the kind of application you're looking for? So you can sort of see how that kind of a meeting might be a lot more successful than one where you have to come back and show the results. So let's build this IoT application now. I just have a few minutes, so this is going to be interesting to see if we can get this going. But that's sort of the pressure of the meeting. Here we are. I'm going to show you this actual Lift application right here. So for this application, we're going to be mixing old technology and new technology. Old technology, we're going to use analog inputs. And the analog input is a IR proximity sensor to see how far this gateway is, or how far the sensor is from the elevator, so the elevator can see how far down and close it is to that landing zone. And also some weight is going to be an analog input. But then we'll use a new device, a newer technology device. We'll use Z-Wave here just for the alerting device. So that will be a strobe siren alert thing. So let's see if we can whip this together. I got a little over 6 minutes, so this is going to be interesting. So let's pull this together. So I'm going to show you the screen of the gateway. So here's the, when you tie in, it's a cloud interface. Right now we can see the devices that we've added to the gateway. Adding devices is really easy, by the way. You just click Manage Devices. You can add Z-Wave devices. You can do whatever you need. So adding devices is easy. For this gateway, I've added just a range of analog ports, digital switches, gauges, dials, things like that. And I've also added the Z-Wave alert device. So this GPIO, I have several things. I have a proximity, I got a joystick, I got sound, I got all sorts of things. We're going to use the proximity sensor here. It's just an analog input. In fact, you can see it's on analog input 5. If you see on the screen analog input 5, it's pointing straight to the ceiling right now. It's a very low number. But if my hand is the elevator, you can see as my hand goes down, that number goes up. So that analog input 5 is about 18. If I go really close, that analog input goes to a much higher number. So now that we know that, let's see if we can take that in consideration. And for the weight, I'm just going to use a slider. So it ranges from 0 to 100 based on, let's just call that weight. All right, let's create the script. Woo, I'm going to cruise here. So we go into the script area. Look at the scripts. I'm going to do a demo script here. We're going to create a new script. I'm going to actually create 3 scripts, one for the 3 different places that elevator might be. So if that elevator is far away, we'll just call this far, then I'd want to make sure that there's no alerting going on. So I'm going to trigger, you can see this drag and drop interface that makes this programming really easy. I'm going to trigger on a device. I'm going to trigger on this GPIO input I have. And I'm going to trigger on GPI input number 5, because that's what I have that proximity sensor tied to. I'm going to say if it's less than 10, then, and I can do more complex triggers, but I'll just say that's the end of that trigger. Then I'm just going to set the alert device to off. And it knows that alert device only has certain valid settings. Siren, strobe, off is one of them. And that's the end of this first simple script. So that's if the elevator's far away, I want to make sure that, no alerts are being sent. So that was up in the cloud. I've now downloaded that script into the gateway, and I'm going to activate it. So that script is now up and running in the gateway. But I need to create 2 more scripts. So I'm going to create one more for the elevators getting closer. So I'm going to create a new script. I'm going to say near. Near. There we go. All right, so this one's a little more complex. So the elevator needs to be close, but not, not beyond its where it needs to be. So I'm going to trigger on that I/O device, that analog input, being in the range of 10 to 30. So I'll say analog input 5. I'll say is greater than 10. And that same device, I could trigger on all sorts of different things, but I'm going to say and that same input, analog input 5, is less than 30. And that just by testing at the table over there, I know that 30 is about the right number. Now, we also say we want to take weight into account. Let's say that the elevator is super heavy. There's a lot of people in it. Well, then you don't want to be so sensitive. So I'm going to put one more and in here. I'm going to say and if the weight of the elevator, which was that input 8, that slider input 8, let's say, and if that is less than 80% of the capacity of the elevator. So I'm going to say less than 80. All right, that's 3 ands in a row. So just say done on that. Now, if this happens, I just want to, so we can have an interesting demonstration, I'll just make an alert of the strobe light. I'll make the strobe light blink. So let's set that to strobe. All right, done. Update gateway, because that was in the cloud, sending it to the gateway, using the cellular interface for this particular example, and activate it. And one last script. If the elevator gets too close, I want it to set the alarm. So I'll say, create new script. I'll say too close. It's misspelled, but I'm in a hurry. All right, trigger on the device, GPIO, that analog input 5, which is where I have the proximity sensor. And if that is greater than 30, let's say. Yep, yeah, then I got plenty of time. Less than 2 minutes, plenty of time. All right, so that's the end of the trigger. What I'm going to do is I'm going to set the strobe light to actually do an audible alarm. That'll wake up everyone. Perfect for the last demo. Siren and strobe. All right, done. That's in the cloud. Send that to the gateway. So now this gateway has 3 scripts all running in it as soon as I activate it. All right, so now the moment of truth. Let's see if any of this works. All right, so elevator, really far away. Let's say the elevator comes down to a normal spot. Yeah, it worked. All right, so that's normal. Let's say the elevator went too far. That worked too. The elevator goes away, turns that off. Now let's say the capacity of the elevator is beyond 80%. So in this case, elevator comes down. It's not even going to alert because we said that, right? We're not going to trigger. But on that last script, you notice that we did not set it to take into account. If that elevator goes way too far, you want somebody to be notified, and so that's where the alarm will go off. And it would have been just as easy to create a text message. I could, just don't have time to do that. Text message to make sure maintenance gets it. So that's how easy it is to create the hardware software solution. You can imagine you're in a customer site. They say, can you do this, that, or the other thing? Absolutely. Pull the right pieces together, show it right then and there, and you can see the power of being able to do that. So I appreciate the time for one question, I think, for the last 20 seconds.
All right, one question.
Last question. Anyone?
Here we go, judges.
Alan, here you go.
You mentioned something about the hardware here, and are you guys also doing hardware or just the software platform? And
Yeah, so the hardware is a Syslink gateway. You saw the picture towards the beginning. We have all the different plug-in modules that go into the hardware based on the interface you need. So if you have cellular or Wi-Fi or Zigbee, you just configure that gateway to exactly what you want. So you don't have to
that's
worry
it.
about getting a fixed solution.
All right, round of
Thank you very
applause,
much.
please.